the beginning of humanity. And with the first glimmer of human consciousness came the need to explain the forces that shaped the world, a world that was seen with awe and wonder. "30,000 years ago, our ancestors carved this figure of their vision of the earth, a mother goddess. And deep within the womb of their mother, in the darkness of her caves, they forged a magical relationship with the earth, and she gave them their daily bread. We have, of course, made progress since then. Our technology allows us to take our first faltering steps away from our mother. A few of us, like the gods themselves, have now gazed down on the Earth, yet our reaction is still that of wonder. For many astronauts, their view of the planet below was a glimpse of divinity. Planet Earth is a wonderful place, its face etched with canyons and mountains, rivers and lakes, and shaped by forces of such monumental power, they're beyond measure. Yet despite such overwhelming power, there is everywhere a thin, delicate veneer of life, its patterns shaped by the same forces that shaped the planet. And as fragile as life is, it's become one of the greatest forces to shape the Earth. But why is planet Earth covered in such a dazzling variety of life? What makes this place so special? And still the biggest question of all, how did it all begin? Our journey of discovery starts not on the planet below, but in deep space. In this distant nebula, stars are being created from gas and dust. But we're not just seeing across vast distances, we're seeing through time itself. When we gaze at the night sky, we see stars and galaxies as they were in the past. Light from this galaxy has taken 78 million years to reach us. If someone was watching us from far enough away, they would see our past, our solar system coming into being, the beginning of our story. 4.5 billion years ago, a vast cloud of dust and gas. It's mostly concentrated at the center, where it's getting more dense all the time, as it collapses in on itself. Growing hotter, so hot it triggers a massive nuclear chain reaction. This huge ball of burning gas swallowed most of the dust cloud, but enough was left over to form tiny grains, which fused together to form rocks, which fused together to form the planets, our solar system. Close to the sun, the heat is intense. With a surface hot enough to melt lead, Mercury is no place to stay. Further away from the sun, the temperature drops far below zero. Comets of ice make their lonely journeys through the cold of space. 200 million miles from the sun, beyond the orbit of Mars, some rock fragments were never destined to build a planet. They remained as asteroids. And further away still, in the outer reaches of the solar system, the distant sun is so far away, the temperature is hundreds of degrees below zero. This is the realm of giant gas planets. Jupiter has no solid surface. But between the extremes of heat and cold, another planet was forming. One like Goldilocks porridge, that was neither too hot nor too cold. Planet Earth. "4 billion years ago, it was still growing, as a rain of massive rocks, meteors, crashed into it, adding to its bulk. The newly formed Earth was a desolate alien place, a dead lump of rock. Just dust and gas and the cold of space. There was no atmosphere, no life, nothing. So how did it turn into the familiar place we live in now? It was a slow transformation. Over such an immense period of time, it's beyond our imagination. But the answer lies beneath our feet, in the very rocks that make up the Earth itself. Some of these rocks, like granite, are radioactive. And as they decay, radioactive rocks produce tiny amounts of heat. It's such a tiny amount of heat that if we tried to boil a kettle by heating it with a cubic inch of granite, it would take about 4 million years. But then there was a lot of rock and a lot of time. The Earth was very patient. The heat from radioactive rocks gradually built up inside the Earth, where it couldn't escape. Eventually, it did more than boil water. It melted the rocks themselves. Planet Earth had woken from her sleep. The Earth was now so hot, it was a raging furnace. The whole planet may even have melted. A vast ocean of liquid rock. Now the molten rock could flow, the lighter materials floated to the top, and the heavier materials sank. The Earth was rearranging itself into layers, like an onion, with different types of rock at different depths. And it wasn't only radioactivity that melted the rock. The Earth was also heated by collisions, as meteors still rained down from space. But eventually, as the radioactive materials decayed, the surface of the Earth began to cool, to form the crust. And as it did, it crystallized into a dazzling variety of rocks and minerals. Tourmaline, muscovite, gypsum, galena. Different materials came together, making different kinds of rock. The Earth's surface, its crust, became cold and solid, but deep inside, the planet was still hot and molten. One of the heavy materials to sink to the center of the Earth was iron. The pressure at the very center is so great, it creates a solid core. But around that, molten iron circulates in massive currents, a slow movement that turns the whole Earth into a huge magnet. In a compass, a magnetized piece of metal lines up with the Earth's magnetic field to point towards north. And for centuries, travelers have found their way round the globe, guided by the Earth's magnetic field. Even today, we still depend on the magnetic field generated by those slow-moving currents of molten iron, thousands of miles below the surface. In the most sophisticated aircraft, a magnetic compass provides a backup to modern navigation systems. Because the Earth's crust is made up of different types of rocks, the magnetic field varies slightly in different places, so the magnetic compass isn't always completely accurate. But some long-distance travelers use these variations in the magnetic field. Every year, barnacle geese make the long journey from their nesting grounds in Greenland all the way to their wintering grounds in Scotland. In good weather, geese navigate by the position of the sun, but if they have to, they also rely on the Earth's magnetic field. We use a compass to find north, which just points us in the right direction. But the geese know exactly where they are. They have a mental picture of the variations in the magnetic field and use this as a map to guide their journey. They navigate so accurately that they can find one tiny island, Islay, off the west coast of Scotland, after a continuous flight of over 1,500 miles. All the geese from Greenland spend the winter here. The Earth's magnetic field does more than guide us on our journeys. It shields us from the solar wind. As our sun burns, huge solar flares, hundreds of times the size of the Earth, eject streams of charged particles that streak towards the Earth at the speed of light. When these particles reach the Earth, most are trapped by the magnetic field. Those that aren't are deflected to the north and south poles. As these particles collide with the upper atmosphere, they create the light shows we know as the Northern Lights, the Aurora Borealis. And the different gases in the atmosphere produce different colored lights. For people all around the Arctic, the Northern Lights were magical. They were powerful spirit beings reaching down to touch the Earth. The Icelandic sagas tell a story of a goddess, Jard, who was so beautiful she appeared as shimmering light. When she lifted her arms, she lit up the whole sky. The Earth and the Moon are the same distance from the Sun, but the Moon is much colder. It has an average temperature of 18 degrees below zero. So why is the Earth so much warmer? If we travel back in time to when the newly formed Earth was forming a solid crust, the surface was cooling down and would have become as cold as the moon. But the Earth is bigger than the moon, big enough to stay hot deep inside, big enough to have volcanoes that belched out gases, carbon dioxide, water vapor, nitrogen. They began to cloak the Earth in a blanket against the cold of space. The Earth now had an atmosphere, but it was one that would kill us in one breath. Carbon dioxide and water vapor trap the sun's heat at the surface, and so, like a greenhouse, the Earth warmed up, getting hotter and hotter. It may have reached 80 degrees centigrade, hot enough to cook most forms of life on Earth, though not a high temperature by galactic standards. Across the galaxy, temperatures vary over tens of thousands of degrees. But from the time the Earth gained its atmosphere until the present day, its temperature has stayed within a very, very narrow range, between 0 and 100 degrees centigrade. And within this range, something special happens, something vital to our very existence, yet something we take completely for granted. Water exists as a liquid. Any hotter, it would vaporize. Any colder, it would freeze solid. So there can't be many places in the universe that experience the miracle of rain. Yet we grumble about it, shelter from it. All we do is complain about it. Only a few of us really appreciate liquid water for the miracle it is. But even more of a miracle, where there is liquid water, there is life. Life, in all its variety, has colored the whole planet. It's water that makes our planet the special place it is, because without it, life on Earth could not exist. Water is the main ingredient of every living creature. It makes up over 90% of our bodies. All the complex chemistry of life must happen in a solution of liquid water. And at the heart of all this variety is one molecule. DNA, the double helix that carries the blueprint for life. From bacteria to humans, this is the very stuff of life. A molecule that can make copies of itself, that can change and evolve. A molecule that can build a creature that can step back and ask questions about the origins of life, about the universe, about everything. The first living molecules appeared very quickly after liquid water began flowing over the face of the earth. That something so complex, so delicate, so precisely constructed could appear at all, let alone so quickly, seems like a miracle. But however it came into being, this molecule, life, changed the world forever. The first life on Earth was a form of primitive bacteria, which flourished in the warm primeval mud. Those first bacteria must have had to live in water that was close to boiling. And this was how life on Earth existed for billions of years. Just bacteria, growing, feeding, reproducing. Nothing else. The descendants of those first life forms are still around today, but only in places that resemble the early Earth. Places like Yellowstone in the United States, where hot water runs freely. Mats of bacteria, hardly different from those first life forms, live around the scalding springs, in water too hot for anything else to tolerate. They carpet the hot rocks with shades of yellow and red. Famous for its steam and geysers, Yellowstone is a window on the Earth's past. Even when the temperature plunges 20 degrees below zero, the hot water never fails. It provides an oasis of warmth in the ice and snow, not just for ancient life forms, but for more familiar, more recent creatures. Bison, with their thick insulating coats, can survive the bitterly cold winters of the high plains, but they come to these natural saunas to thaw out. Why is Yellowstone such a bizarre place? Where is the heat coming from? A plume of molten rock has risen close to the surface. In the distant past, it caused eruptions of such power it devastated huge areas. It might be quiet now, But there's no reason why it can't erupt again. The Earth is still a very active planet, still evolving, still changing. The Earth's crust is not one solid piece of rock. It's broken into huge, separate plates. Like a global moving jigsaw, these plates are slowly drifting round the planet. They ride on top of the Earth's mantle, rock that creeps and flows like sticky toffee. And where continents collide, volcanoes are born. Where two plates meet, one plunges down under the other. The rock forced downwards is under so much pressure it melts and forces its way back towards the surface. Underground chambers hold reservoirs of molten rock, magma, and when enough pressure builds up, the magma bursts out as a volcano. And different types of molten rock produce different kinds of lava. As the most active volcanoes are in Hawaii, scientists call different types of lava by their native Hawaiian names. Sometimes it's slow and sticky and crumbly, called a'a. Another kind of lava is more runny. It flows more quickly. Folding over on itself like batter, it has a ropey texture. This lava is called by its native Hawaiian name, pahoehoe. If plates are colliding in some places, they must be pulling apart somewhere else. North America is parting company from Europe at about the same rate that fingernails grow. But the line of separation is hidden deep beneath the Atlantic waves. These two plates are pulling apart along a ridge of volcanic mountains that runs down the middle of the Atlantic Ocean under 3 miles of water. It takes equipment as sophisticated as the space shuttle to explore these depths. And in the crushing pressures of the deep sea, we found things we could never have imagined. Black smokers, water at 300 degrees centigrade erupting out of the rock, carrying minerals from deep underground. Black smokers exist because there is molten rock just beneath the surface. Water seeping into the rocks through cracks is heated and erupts back out into the sea, carrying minerals that color it black. That same lava will eventually create new seabed when it wells up to fill gaps left by the separating plates. But even more startling, there is life down here. Colonies of shrimps live on bacteria similar to those first primeval bacteria, and the bacteria get their energy from the minerals gushing up in the smokers. This is life, but not as we know it. These are among the very few creatures on the planet that don't ultimately rely on sunlight. The volcanic ridge in the Atlantic joins with similar ridges in the other oceans, creating the longest mountain chain in the world. In the Pacific Ocean, the black smokers support strange gardens of tube worms, over 3 feet long, again living off bacteria, this time inside the worms. The discovery of black smokers has raised a whole new set of questions. Some people even think that this is where life first appeared on Earth. Could these deep, pitch-dark volcanic vents be the source of everything that lives on the planet? As yet, no one knows for sure. In fact, we know less about these hidden depths of our world than we do about the surface of Mars. This great volcanic mountain chain is submerged under 3 miles of water. But in the Atlantic Ocean, there is one place where the ridge rears its head out of the sea. Iceland. Halfway between Europe and America, Iceland sits on the northern end of the ridge where the 2 plates are tearing themselves apart. "1,200 years ago, an Irish monk, St. Brendan the Navigator, arrived here after a dangerous journey across the Atlantic from Ireland. He could never have imagined such a place, and he was convinced he'd found the gates of hell. St. Brendan wasn't far wrong. The fires of the underworld are very close to the surface here. Iceland is the most volcanic place on Earth. The Icelandic sagas tell of how the world began, but they also speak of the end of the world, Ragnarok, a time of fire and smoke when the gods will return from whence they came and the world will be no more. In 1973, the island of Heimaey, off Iceland's south coast, had a private glimpse of Ragnarok. A volcano erupted close to the town, raining showers of ash and molten rock on the houses and spraying lava hundreds of feet into the air. Over 360 homes were completely lost, burnt or buried under the volcanic ash. Another 400 were damaged. But there are advantages to living on the mid-Atlantic ridge. Hot water, and plenty of it. Apart from providing year-round bathing, hot water pumped from underground heats greenhouses, homes, businesses. Heat from all the volcanic activity just below the surface means Iceland has energy to spare. Iceland may be a land of fire, but close to the Arctic, it's also a land of ice. This is the biggest ice cap in Europe, the Vatnajökull Glacier, a slab of ice almost 2,000 feet thick. And underneath this huge glacier, in October 1996, just as described in the great sagas, the worlds of fire and ice met. A volcano erupted, melting the ice at the bottom of the glacier, creating a violent explosion of steam and ash. Melting a glacier produces a lot of water. But after the eruption, nothing happened. For weeks, life went on as normal. On the surface, everything seemed calm. Just the normal slow melting of the glacier. Then, on November the 5th, 4 weeks later, the water found a way out, and the flood began. Almost a cubic mile of water had been trapped under the ice, and it was released in a matter of hours. The flood was devastating. "30-foot-high boulders were swept along by the torrential waters. This was Iceland's most destructive flood in over 60 years. Roads were destroyed and buildings demolished, yet surprisingly, there was no loss of life. The island's largest bridge was specifically designed to withstand floods, yet it was swept aside like a broken toy. The cost of the damage, though, would be close to $12 million, and the population of Iceland is only 250,000 people. But out of the chaos, when ice and fire had fought their battle, the flood subsided, and calm and life returned to the land. Arctic terns nest on the debris from the flood. Living in a land of such extremes, it's not surprising that ancient Icelanders, in their great sagas, saw the living world as being created between the worlds of ice and fire. And they were right. This is the reason why planet Earth is so special. It was created between the extremes of heat and cold. But our story isn't over yet. Life had still to play its most dramatic role. For billions of years, in fact for most of the history of life on this planet, there was nothing but ancient bacteria. And then, something new, something devastating that would change the face of the planet forever. A new form of life, a green form of life, began to use the energy of sunlight to make its food from carbon dioxide and water. But this process produced a deadly waste, pure oxygen gas. Oxygen gas was poisonous to the ancient bacteria. They were forced to retreat to places where the gas couldn't reach them. This was the worst case of global pollution the Earth has ever known. As the new life forms spread, oxygen began to build up in the atmosphere, creating the air that we breathe today. But it did even more than that. Oxygen turned the sky blue. Life is adaptable. New conditions create new opportunities. Creatures arose that could make use of all this oxygen. And these were entirely new kinds of creatures, complex creatures. No longer microscopic, they were made up from many different kinds of cells working together. "600 million years ago, there was an explosive burst of evolution. And within a short period of time, every major design evolved. Every kind of body plan that has ever existed. Nothing radically new has appeared on Earth since that time." Eventually, life left the cradle of the oceans and invaded land. Life had claimed the whole planet for its own. For all we know, planet Earth may be unique, the only place in the universe where life flourishes. Or it may be that wherever there's liquid water, there is life. Either way, this is the only world we know, if not completely understand. With every passing generation, our comprehension grows. But at the end of our journey, we arrive where we started, a world more full of wonder than we can understand.